If you're a beginner or even an intermediate with Python, then these 5 Python concepts can absolutely take your Python programming to the next level. If you're someone who's taking yourself seriously as a programmer, one thing you should absolutely always be doing is upgrading your knowledge in your chosen programming language. If that language for you is Python, then you're in the right place, because these 5 concepts are something that every serious Python programmer should be aware of, or otherwise bad things will happen to you. Seriously, not understanding even one of the concepts in this video could be what's holding you back from building projects that can really impress in your resumes or succeeding as a developer in a real production environment. So please just learn these topics, and I'm sure some of you might already know a couple of these, but I guarantee you that you will walk away from this video with at least one new concept that you can then immediately apply to your projects and become a better Python programmer. But before we get into that, if you like my teaching style and you want to go through a full program from zero to getting hired as a Python developer, then I also have my full program down below, which you can check out, where we learn not only Python programming but also object-oriented programming. We learn web development, we learn how to build projects, what kind of projects to build, and of course all the technical and non-technical skills you need to actually get hired in the real world, even if you don't have a degree and within 6 months or less. So if you're interested in that, go check that down below, and with that, let's get into the video. So the first concept we're going to talk about is something called object reference parsing. So this all relates to how Python deals with function parameters and how things are passed into functions. Well, imagine you have a function like this called modify list that takes in a list as a parameter. Then what we do is we append something to that list. So quiz time. What is now going to happen to that same list outside of this function? Is it going to be modified, or is that list also going to now have that new item or not? Well, it turns out that it is, because in Python, mutable objects, aka lists and dictionaries and objects that you create yourself, are passed as what's called a reference. So what really happens when this list is given to this modify list function is that we simply get a reference to the place in memory where that list is stored. And in my program Python Developer Bootcamp, we go into a lot more detail about like the memory and how everything is stored. But the basic idea is that every variable in Python occupies some what I call memory boxes inside of the computer's RAM. And when you store variables, what you're really doing is storing pointers to the places in memory where these things are stored. Alright, so when you pass a list or a dictionary or an object to a function, what you're really passing is just this reference to that place in memory where that list is actually stored. So when you then modify that list inside of this function, what you're actually doing is modifying the actual list that is inside of the memory. And then outside of that function, if you have a different reference to that same place in memory, it will have been modified, because you're actually modifying the actual thing in the memory. And this is really good to understand, because in your programs, you pass things to function. You might be confused as to why some of them are changing outside of the function and some of them are not. So that is object reference parsing. The next we have is list comprehension. So list comprehension is essentially just a quick way of making a list. Let me show you. So let's say what I want to do is take a list of numbers from 0 to 10, and I want to make another list that are the squares of all of these numbers. So what I might do is go to Python and create a variable called squares, which I'm going to initialize as an empty list. And then what I might want to do is run a loop for I in range 10, which essentially just creates what's called a range object with numbers from 0 to the number that we give it, which is 10. And then what I want to do is in each iteration of the loop, I'm just going to go squares append I squared, which we denote by this double multiply sign right here. And this, if we then go and we print squares afterwards, is going to work, right? Because the actual list of numbers will be 0, 1, 2, 3, etc. The squares of them will be 0, 1, 4, which is the square of 2, 9, which is the square of 3, 16, which is the square of 4, etc, etc, etc. But you might see that this is a bit verbose for like such a simple operation. So what Python actually has is a syntactic way of doing this a lot more simply, which looks something like this, where essentially what we're doing is, without needing these 3 lines of code in here, we simply have 1 line of code where we have squares, and then inside of it we have a list with x squared 4x in range 10. So this is essentially just a syntactic way of doing the same thing right here, where what it does is it runs a loop 4x in range 10, and then what happens is that it's going to create a list where every element of the list is going to be this expression right here. So x squared. Just stop the video and make sure you understand what this is doing. And there's many different things we can do with these list comprehensions. We might imagine an original list, and we might imagine wanting to essentially filter this list so that we only get items that are divisible by 2. But we can do that is go num for num in original list. We can actually append this with an if condition. So this num will only be added to the new list. It is divisible by 2, which we do with this operation right here. We can also run a nested loop using this syntax. This is a bit more tricky, but we have x, y, which is a tuple, for x in range 3, for y in range 3. So let's just see what comes out of that. So the coordinates are essentially going to be just like a nested loop. We can apply any sorts of operations. So we can apply name upper to this list right here to get all uppercase names. And there's a bunch of other things we might do here. So a really sleek syntactic way that's going to really impress in interviews if you can use this. So worth learning to use this concept. Next, we have something called lambda functions. So these are what's called anonymous functions in Python. So to introduce you to this, what we have here is a function called double. So essentially what this does is just takes an x and then doubles it, so multiplies it by 2. But you might see that this is a bit verbose, like we're having to use 2 lines of code and write this def and the function name and all this, when we just have a very simple function. We're just running 1 line operation. What Python actually allows us to do is do this a lot more simply using something called a lambda function. Something like this, which looks a bit cryptic at first, but it's actually a lot easier. So instead of defining the function in the usual way, what we do, we simply create a variable called double to lambda x colon x times 2. Okay, so what is happening here? So when we set a variable equal to lambda something, what that lambda is telling us is set double to be a function. It's essentially going to be a 1-line function where that function is going to take as a variable x, and then the operation that it's going to run is x times 2. So now double is not just a variable, it's a function that we can call in the same way as any function. This is essentially just what we call syntactic sugar for this right here. This is a shorter hand way of defining these functions that we might only need like 1 time or a couple of times, and defining this function in this usual way would sort of be unnecessarily verbose. So other ways to use this, you can take 2 variables inside lambda functions just like you can with normal functions and do operations like this. And also often we use lambda functions when we're needing to pass functions as arguments to some other function. So for example, this sorted function in here, what it does if you hover over it is it takes an iterable, which is this list points in here. And then as an optional second argument, you can take what's called a key, which as it describes it here, a custom key function can be supplied to customize the sort order. So what this does in here is that before any comparison happens, so the way the sorted function does things is it compares items and then it determines which one is larger and which one is smaller. So before any comparison happens, this function is going to be called where it just returns the index 1 item. So for example, when these 2 are being compared by the sorted function, it first just takes the second item in these tuples, and then instead of comparing these tuples, it just compares the second item. So essentially what this is saying, that we're sorting these points simply based on this second value or the y value of these coordinates. And that is indeed what happens here. We have 1, we have 2, and we have 3. Now what you could have done is defined a function outside of it called, I don't know, key. You take in an x and then you return x1. That would be the same thing, and then we could just set this like this. But that would be quite verbose. Like we might not want to have to define this function like this when we literally just need it in this one place inside of this sorted function. So those are lambda functions, which are actually going to be very useful in the next thing concept that we are about to talk about now, which is functional programming. All right, so in programming, you might have heard about something called object-oriented programming, which essentially just refers like using classes and things like this. Now, functional programming, which is what's called a programming paradigm, which is essentially just a fancy word for a style of programming, a way of programming. It essentially just refers to preferring to use different kinds of functions that don't actually modify data in our program, but instead simply returns values, and then those values are used in the next function, etc, etc, etc. Now this is a much wider concept that we talk about again more inside of my program Python Developer Bootcamp if you're interested, but let me just show you the absolute basics. Now with functional programming, there are a couple of specific functions that we use very often. These are called filter, map, and reduce. So what filter does, it's a function that takes in some data like a list and then filters it based on some condition. Map takes in a list or some other iterable and changes each item in some kind of way. Whereas reduce combines all the items that it takes into one result. So it sort of reduces it down to a single result. Let me show you how this works. So here we have a function called isEven that simply just checks if a function is even or not. So we have a list of numbers. Then what we're going to do is apply a filter function where the first argument is going to be the condition, the sort of checker that we want to pass to each item. And the second is going to be the list that we want to actually filter. So what this does is it goes through this numbers list, and for each of these items, it applies this function right here. And if the function returns true, then this new list, even numbers that is returned here, is going to include that value. Otherwise, it is not going to include that value. So if we were to run this and print this, which we're actually going to do, we have 2, 4, and 6, because only those items return through from this isEven function. Now, trivia question. From our previous concept, what might we improve about what we just did here? What is sort of unnecessary here? Well, that's right. We have a function that just has one line that we're defining in the usual way. What we might want to do is use a lambda function and instead define it inside of the filter function, just like this, which makes this much less verbose. So that is filter. And by the way, the reason why we're still calling this list what we call casting function afterwards is because, strictly speaking, this filter function returns something called a filter object. So if we want to turn that filter object into an actual list, then we simply call this list casting function afterwards. So now this even numbers is going to be a list. So the other functional programming function is going to be something called a map, which we can see here. So what map does is it similarly takes a function as a first parameter and a list or some other iterable as the second item. So we're using the same numbers array. And what it does is he transforms each item into something else based on some condition. So for example, in this case, we have a lambda function. What it does is it takes an x, when each iteration, this x is simply going to be each item of this numbers list in turn. And then what it does is it transforms each of these into x times x. So if we run this again, we can see squared numbers. So it's essentially just squares all of these. And this right here, as you might see, is another way of doing the same thing as we did here with our list comprehension syntax. In this case, I don't really know which one is better, which is worse, it's personal preference, but it's just another way to take in a list and apply some operation for every item of that list and return a new list. Lastly, we have reduce, which is, I guess, the most complex out of these. But what it basically does is, again, it takes a function and a list. And then what it does is that it keeps track of something called an accumulator. So in this case, this function here actually takes two parameters. The first one is going to be what's called the accumulator, and the second one is going to be the parameter that actually refers to every item in this list. So what this does, this accumulator actually remains the same across every run. So in the first run, the accumulator is just going to be 0. And then what's going to happen is going to add y, which is going to be 1, to the accumulator. And then what is returned out of this function is now added in the accumulator. So in the next run, the accumulator is going to be 1. So we're going to have 1 plus the second item, which is 2. And that is again going to be returned and added into the accumulator. So what this particular reduce function actually does is it just adds all of these items in the list together into one value, which is actually the value which is then returned out of this reduce function right here. Might take a second or two to get this, but again, very, very useful tools that I actually use very often in my actual programming, these filter, map, and reduce functions, which are a great introduction to functional programming. If you want to read more about functional programming, I'll leave some articles down below. Last but not least, we have decorators. Now, decorators are something that I've been aware of for a long time, but I've never actually gone into the habit of using them myself. So this is something I'm actively trying to use more in my own programming. So first, let me show you how it works, and then we'll sort of talk through the anatomy of what is actually going on. So here we have this situation in here, which is actually simulating something that I'm doing in an actual program that I'm writing, this like flight mapper. I'm essentially making this program to like take flight prices and like make a whole map of it. I'm figuring out how to do that. Just a simplified version of what is going on here. So I have this function get flights, and I have this function print prices. And what I want to do is whenever any of these functions run, just to keep track of which functions are running when and things like this, I want to print to the console whenever either of these functions runs. So of course, what I could do is simply go and print and write like running function, whatever, but that would require me to repeat code. And as programmers, we want to be lazy and we want to reuse the same thing as much as possible. So what we can do is apply something called a decorator, which has this really funny syntax of this @ and then this name of the decorator. So what happens here is that we define a function which is going to be a decorator function. And inside of it, we do a bit of a weird thing. We define what's called a wrapper function inside of it. So it's like an inner function, a function defined inside of a function. What this does is it simply returns this wrapper. So essentially, when you run this wrapper function is going to be returned. So then what we do is we apply this function as what's called a decorator. So what this means is that whenever we run get flights, for example, what it's actually going to do is run the log function run function and taking this function as a parameter. So in Python, functions are what's called first class objects, which essentially just means that we can pass functions around different functions as parameters. We can return them. We can do all the things with functions that we can do with any other type of object in Python. What happens is that this flight prices function is passed as a parameter to this log function run decorator, which is going to run instead of this function. And then what happens here is that this wrapper function is ran, and inside of this wrapper function, we're printing this line in here, running function, and then we use the syntax to get the name of this func, which is the function, this function right here. And then after that, we actually run the actual function as we are supposed to. So we apply this decorator to both of these. And when we run this function, we get this in our console. We get running function, get flights, which makes sense because we're running it first. And then we get fetching flight details. So the actual function is run after that. Then we get the same thing happening for this print prices. So what is actually happening here is that this log function is syntactic sugar for something like this, where we go get flights is equal to, and this should actually come after this one, like this, where we take the get flights as a parameter. Okay, so let's unpack this. What is happening is we are defining a variable, get flights, which is going to be equal to the return value of this log function run function with the get flights function as a parameter. All right, so to get the value of this get flights, this function will have to be run. Okay, so let's run this function. When we run it, we define this wrapper. Okay, interesting. And what is returned is this wrapper. So actually when this runs, it doesn't yet run this wrapper function, because what we're simply doing is returning this function, right? So when you run this, what it's going to return is whatever this function is. Now, essentially, this get flight function is simply this wrapper function, just like this. With, by the way, these args and quarks just refers to the arguments and keyword arguments that we might be passing to one of these functions if, let's say, this had variables x, y, things like this. All right, so get flights is now actually just equal to wrapper. So what now happens is when we run get flights, it actually runs the wrapper function, which then prints this thing and then returns and runs this get flights function. And because we are returning this with these parentheses, that is actually saying don't just return the function, but also run the function, return the return value of this function. I know that that was absolutely a lot, but just stop the video and sort of walk through this logic to see that it makes sense for you. And we're going to leave further resources down below if that did not make sense for you. So the reason why this is useful is because using syntax like this, we can apply the same wrapper operation to any number of functions that we want without having to repeat this line in like all the places where we want. But because this is such a repeated pattern, Python has made it easier for us by allowing this syntactic sugar of this wrapper syntax. So essentially, we don't have to write this, which is quite verbose and like tough to remember. We can simply write this add log function run, which now essentially does that same thing, where essentially when this decorator is applied, instead of whenever this function is run, instead of running this function itself, it's going to run this wrapper function inside of this decorator. That is the net effect of this very sort of complicated and convoluted operation. So you might not yet be convinced why this craziness is even necessary. So I'm just going to show you a couple of examples where this can be useful. So let's say you want to time the run of any given function. Now what you might want to do is just define a start time and then define an end time after that function is run, and then print how many seconds it took to run that function. Of course, you could simply define this anywhere inside of any given function, but if you have a million functions and you want to quickly apply the same time it to many functions, it's a lot easier to define that in one place as a decorator and then apply it to whichever functions you want. So what this does is that when you run this function with this decorator, remember, instead of actually running this function, it just runs this wrapper, which just extends the behavior of this original function. So what it does is define the start time, then it runs the actual function, which is the func, which was taken as a parameter for the decorator. It gets the result because we still want to access the result. We get the end time. We first print how long it took to run, and only then we return the result, which is the original thing that should have been returned by this function. So essentially with decorators, we're just extending the behavior of the functions, where you can then apply that same behavior extension to however many functions as you want. But if this seemed like complete nonsense to you and you don't even feel like you have the required Python fundamentals, you don't feel like you even know enough about the basics to even get into these like slightly more advanced, like intermediate kind of concepts, then I highly recommend that you check out my program, Python Developer Bootcamp, where we go through everything from literally first principles. Literally, if you feel completely lost with programming, I explain everything you need with Python, with OOP, and with everything you need to get hired in such a way that literally anyone can understand. And I actually give you the skills to actually get hired at the end of it. So go check that out down below. I hope that at least some of this was new to you. I hope that this was helpful to you. Now, if you're looking for actual projects to build, I actually made this video where I give you 5 ideas for really impressive portfolio projects in Python that you can build. So go watch that video, pick a project or two, and then pick concept after concept and start bringing them into your programming toolkit, and that will make you such a better programmer over time. So go watch that video and I'll see you there.